Hello students, how are you all? So in our last video we talk about that how the load and effort will work, what is the load arm, what is the effort arm, and we talk about also the levers. This time we have to do some sums according to that I have taught in the last video. So in this part I'm starting with the number 2. The length of the lever, that is 3 meter. Calculate the mechanical advantage of the lever if its fulcrum is situated at a distance of 120 centimeter from the load. So we know that for a lever, the fulcrum and the load is situated in some different places, and in here the length of the lever, the total length, that is given as 3 meter. We know that we can convert that meter into centimeter. So it will be 300 centimeter. Those who don't know how to convert all this thing, please write down this conversion method. So first of all, kilo, hectare, deca, gram, deci, centi, milli. So these are all the conversion part, where if something is given in 1 kg, we write it as 1000 gram, right? So that means we have to travel 1, 2, 3 step to reach to the gram. So it will be, for each of the steps you are multiplying 10 to move in right side. So how we did that? We are moving in right side. That means we have to remember we have to multiply 10. Okay. Now how many steps we are moving? That is 1, 2 and 3. So we have to multiply 310. That means 1000. So 1 multiplied with 1000 become 1000 itself. Also, if you want to remember like this, in left side if you move, then how much step you are moving? That is 1, 2 and 3 again. So you are moving in left side. For this you have to do the reverse one. You have to do right now the division. So while you will do division for each of the steps, you will divide it by 1000 and it will be 1000 by 1000 will be 1. So similarly, for each step in right side you have to multiply 10, and for each step in left side you have to you have to divide for 10. Now remember one thing, as I put over here gram, you can also put meter in this position. So kilometer, hectometer, decameter, decimeter, centimeter, millimeter, it will name like that for this case. Okay, so idea is clear about the conversion. Still, if you have any doubt, you can ask me in the group. I will surely help you. Okay, so coming to the next part, the total length of the lever is given as 3 meter. So kilo, hectare, deca, gram or deci, centi, milli. So centi and milli, or up to, let me write it first. After that, it will be very easier to you. Kilo, hectare, deca, meter, deci, centi, mil. As you can see over here. So we have to come from the meter to centimeter. Okay. So how much path we have to travel? That is 2 step, 1 and 2. In right side we are traveling. That means for each part or each step we have to multiply 10. So that will be 100. We have to multiply with 100. So it will be 3 into 100 centimeter or 300 centimeter. Very simple if you do it like that. Okay. So we have the total length as 300 centimeter. Right now, the length of the load arm, that is load arm, is given as 120 centimeter. Okay. So what should be the effort arm? We know that if we start it from fulcrum, then it will be load arm from fulcrum to here, it will be 120 centimeter. Then from fulcrum to the another end, that is the effort position, that means nothing but the total length, which is 300 centimeters. So the arrangement is given like this. So we got now the total idea about load arm and effort arm. So we know that what is the mechanical advantage? That is the division of, or the ratio of, we will learn at division of the effort arm to the load arm. So write down the formula first. You also have to write the or draw the diagram for this case. It will be better if you draw this one. So first one is effort arm, that will be divided by the load arm. So what is the value? That is 300 divided by 120. Cut it with 0. Then come with 3. It will be 4. It will be 10. After that it will be 2. It will be 5. So finally you will get 5 by 2, and if you convert it into decimal you will get 2.5. Suppose if someone want to write this as fraction, then it is also applicable as answer. Okay, but I will recommend to convert it into decimal. It will look pretty nicer than this fraction. Okay, so moving to the next one, that is number 3. First of all, in number 3, a man uses 2.5-meter long crowbar, okay, and raises a load of 1000 Newton. So the load value is exactly given as 1000 Newton. That is our load. Coming to the load arm, that is also given as 2.5-meter long. So we can write it as, sorry, it will be not 2.5 meter. The total crowbar length is given as 2.5 meter. So So further, the effort needed to lift the load, we have to calculate that one. The mechanical advantage of the crowbar, the fulcrum is located at 2 meter is given from the effort. So we know that the fulcrum, let me draw it first. The fulcrum is situated in somewhere here. This is the load and this is the effort. So what should be the arrangement for this one? The effort arm, or the effort arm will be 2. It is given over there, 2 meter. Okay, the total value is 2.5 meter. Then what should be the load arm? 2.5 minus 2, that is this part. 0.5 will be the value. So load arm, that should be equal to 0.5 meter. Okay, so we have right now load arm and effort arm, that is already given as 2 meter. We have to find that how much effort we are going to put over here. And remember or not, I told you in the last class that effort into effort arm, that should be equal to load into load arm. So if you rearrange this value, you will get effort equal to load into load arm divided by effort arm. So finally, as you can see over here, load value is given as 1000. Load arm is given as 0.5, that is nothing but 1 by 2. You can also write 1, and in the denominator you can write as 2. Also effort arm value is 2. So if you cut it with 2, it will be 500. Again you can cut it with this 2, it will be 250. So the effort value will be 250 Newton. Don't forget to give the unit. It is very important. So it will be 250 Newton as the effort. Okay. Now coming to mechanical advantage. Now how we can find that mechanical advantage? We know the formula, that is load by effort. That is all about mechanical advantage. You can also write M capital dot A. You don't have to write the total word. Okay. So load by effort, we know the values, that is 1000 for the load, and for the effort we have 250 and also 1000 Newton and 250 Newton. Newton and Newton units are getting cancelled. That means no unit will be happen for the mechanical advantage. Now coming with the calculation, that is 250 cancelling this 1000 with 4. So we are having the mechanical advantage as 4. So this is the sums, and this type of sums is going to come in your exam. So please carefully practice all this, and still if you have any doubts regarding this sum, don't forget to ask. Now coming to inclined plane. What is that? Inclined plane is actually a angular slant base where it has some inclination with the ground. So how it will help you to the work? Whenever you will put something from the ground to a certain height, if you do it very manually, you need more work or more energy in this case. But by using this inclined plane, if you started to slide this box, it will be very easily move upward. Similarly, if you started to unload the truck or whatever over there, you can slide that box down. So the energy required for this case by using the inclined plane will be very less. So that is the advantage of inclined plane. And by this inclination principle, we actually use the wedge shape. Now what is that? For wedge shape, we actually use this one at the bottom of the knife as well as at the bottom of the needle. That's how wedge shape is work. What is that? That is actually the join of two inclined plane, where if you notice the knife, the very bottom sharp part, then it will look like this, very sharp. Also, if you look at needle, it will also look like this. So this part, this small sharp part is known as wedge shape. That is actually increase the pressure at a certain point, which help us to cut or to penetrate in a certain point. I hope the idea is clear. The main keyword is that it increases the pressure at a certain point, which is very helpful for us to work with limited energy and having the maximum output. Coming to screw, this is also having the same kind of principle, but in this case we can rotate that screw. That means we can use the rotational energy to penetrate to some wooden or plastic or any other blocks. So we also know that by using the screwdriver, if we rotate that screw, it is also using that wedge shape principle, where in this part at the bottom you can see that wedge shape is there, and when you are putting the pressure of rotation in a certain point, it is getting penetrated to a certain object or medium, and that is how we are having the screw over there. So, and also during the, as you can see, the circular spiral parts are there, and that spiral parts actually generates more friction and very high grip for and also as you can see the circular parts are there, which is giving you more friction and nice grip to having a perfect rigidity over there. Coming to pulley right now, what is pulley? There are two kind of pulley. You always maybe noticed all this pulley in hydraulic lifter or in any other normal work. As you can see in at the top of well, we use this kind of pulley to pull up the bucket with full of water. See, if you try to pull up the bucket with full of water by your hand only, then you will feel you have to put so much energy in this part. But while you are using this kind of pulley, the work will be very easier, because in this part you are pulling it in downward, and by this effort your gravity is also helping you. So in this case the energy is quite less comparing to normal work. So that is why we use pulley. There are two kind of pulleys, that is single pulley, single fixed pulley, and single movable pulley. So in single fixed pulley, it is fixed at a certain point of rotation, where in single movable pulley, it is not fixed with the axis of rotation. That is the most important difference between them. I hope you get that idea. Now moving to the wheel and axle arrangement. You might notice at the first wheel of that, or also the back wheel of the four-wheeler, that the wheel is constructed like this. So as you can see over here, this wheel is connected with this axle. So whenever the axle got some rotation, the wheel also have the full rotation. So which actually increase the rotational power with a small rotation. And that is also efficient for the energy. So this is all about the idea of wheel axle arrangement. So what is the important thing in this chapter? The important things are levers, and also the sums like mechanical advantage, load arm, effort arm, this kind of relations, and also the applications of wedge shape, inclined plane, screw, pulley, wheel axle, and all this. So I hope you get that idea. Still, if you have any doubt regarding this chapter, you can ask me anytime. I will give you the chapter solution very soon. So thank you for your time.